Hi, in this video, we are going to be looking at using the ratio or the root test in order to determine convergence or divergence of a series. And what we're looking at here is the series from 1 to infinity of n squared plus 3 over 3 to the n. Something worth noting right away is that because our numerator is a polynomial, specifically a quadratic, and the denominator is an exponential, we should expect this series to converge. Exponentials significantly dominate quadratics. Something else we should observe is that the ratio between subsequent quadratic terms tend to converge to 1, whereas the ratio of subsequent exponential terms tend to converge to the value of the base, so 3 or 1 over 3, depending on where the subsequent terms are. And so because of this, it makes sense to employ the ratio test in order to determine this convergence. So by the ratio test, we should be looking at the limit as n goes to infinity of a sub n plus 1 over a sub n. And so first thing we want to note is that we can drop the absolute values. They're really not doing much for us since all of our terms are positive. The next is that when we evaluate at n plus 1, we get n plus 1 squared plus 3 over 3 to the n plus 1. And then rather than divide this whole thing by a sub n, I'm just going to multiply by the reciprocal for ease of writing. 3 to the n over n squared plus 3. And that is, I'm just going to also once again briefly rewrite this as I think I'll need to go to a new line. The limit as n goes to infinity of n squared plus 2n plus 4 over, and here we have n squared plus 3, 3 to the n plus 1, 3 to the n. Now, something we should note right away. Um, 3 to the n is n copies of 3 multiplied together. And 3 to the n plus 1 is n copies of 3 multiplied together. And then another 3, right? N plus 1 copies of 3 multiplied together. So this allows us to rewrite this expression as 3 to the n times another 3 for n plus 1 3's. And so now we have 3's in the numerator and denominator, so this allows us to rewrite our expression as the remaining 1/3 times our quadratic stuff. But when we look at the quadratic stuff as n goes to infinity, we should first note that by definition, this is a rational function whose numerator and denominators have the same powers. So this already tells us that this should converge to a constant that's not 0. Specifically, because they have the same leading terms, it should converge to 1. Repeated applications of the L'Hopital's rule would have given you the same result. So we're going to get 1/3 times 1, which is 1/3, which is less than 1. That means as n approaches infinity, each term is going to be about 1/3 of the previous term. And that means the series behaves like a geometric series as n increases, where the common ratio is 1/3, which makes sense because we have a 3 to the n in our denominator. And so thus this series converges by the ratio test. All right, thank you very much. I'll see you in the next video.